The coil traverse data with rotating vane method was developed to measure airflow at coil faces using a vane anemometer. The method can be used on any coil, provided there is no moisture carryover. This procedure was developed in the ASHRAE Research Project 451, Airflow Measurements at Coil Faces with Vane Anemometers, Statistical Correlation and Recommended Field Measurement Procedure by Harry J. Sauer, Jr., Ph.D., P.E., and Ronald H. Howell, Ph.D., P.E., documented in the 1990 ASHRAE Transaction Volume 96, Part 1, pages 502 through 511. The coil traverse data with rotating vane form was developed to calculate the coefficient algorithm represented by K, known as the K-factor. The K-factor is automatically calculated using the following formula. K equals A0 plus A1 multiplied by average coil velocity plus A2 multiplied by the number of tube rows deep in the coil plus A3 multiplied by fins per inch plus A4 multiplied by tube spacing of the coil plus A5 multiplied by the tube outside diameter plus A6 multiplied by average coil velocity squared. To start the process, submittal data is recorded into the coil traverse data with rotating vane form, which is then verified in the field. This AHU-1 submittal data was provided and used to input the highlighted measurements into the form. The data is recorded as decimals and not fractions. The measurements are recorded using the inch-pound unit of measure. The diameter of the rotating vane head and the tube spacing of the coil was not included in the AHU-1 submittal data. These measurements were taken while in the field and recorded into the coil traverse data with rotating vane form. From the submittal data, record the height of the coil on row. H equals height of coil as 43.5. Notice the coil reading dimensions are automatically calculating on the right of the form. From the submittal data, record the length of the coil on row. L equals length of coil as 75. Notice the coil area is automatically calculated on area equals coil area as 22.66 square feet. Verify the coil area with the submittal data sheet. On the AHU-1 submittal data sheet, face area is documented as 45.31 square feet for two coils, top and bottom. Therefore, each coil's face area or coil area is 45.31 divided by 2, which is 22.66 square feet for the top coil and 22.66 square feet for the bottom coil. From the submittal data, rows, record the number of tube rows deep in the coil on rows equals number of tube rows deep in the coil as 2. From the submittal data, record the number of fins per inch on row. FPI equals fins per inch as 8. From the submittal data, tube OD in inches. Record the coil's tube outside diameter on row. OD equals tube outside diameter as 0.625. On the AHU-1 submittal data sheet, the airflow CFM design is documented as 16,500 for two coils, top and bottom. Therefore, each coil for the airflow CFM design is 16,500 divided by 2, which is 8,250 CFM for the top coil and 8,250 CFM for the bottom coil. The coil traverse data with rotating vane form has been populated with the AHU-1 submittal data. Next is to verify the submittal data while in the field, and to complete the form by measuring the diameter of the rotating vane head and tube spacing of the coil. Then the coil reading dimension data on the right will be automatically calculated. This data will be used to measure and mark the coil for the standard velocity reading locations and the offset velocity reading locations. In the following video, an uninstalled demonstration coil was filmed to demonstrate how to verify the submittal data measurements and mark the coil for standard velocity reading locations and offset velocity reading locations. This coil will be installed in an identical air handling unit. It has identical dimensions to the top and bottom coils of AHU-1. Measure the height of the coil in inches and verify that the actual measurement matches the submittal data on the form, which indicates the height of the coil as 43.5 inches. Measure the length of the coil in inches and verify that the actual measurement matches the submittal data on the form, which indicates the length of the coil as 75 inches. The AHU-1 submittal data did not include the diameter of the rotating vane head. The DIA measurement was taken while in the field by measuring the inside diameter of the rotating vane anemometer's head as 4 inches. Next, record the measurement in the coil traverse data with rotating vane form on row DIA equals diameter of rotating vane head as 4 inches. Notice the coil reading dimensions on the right are automatically calculating. The AHU-1 submittal data did not include the tube spacing of the coil. The tube spacing of the coil was measured while in the field as 0.875 inches. Next, record the measurement in the coil traverse data with rotating vane form on row SP equals tube spacing of coil as 0.875 inches. Count the number of tube rows deep in the coil and verify that the number matches the submittal data on the form, which is indicated as a count of 2. Measure and count the number of fins per inch and verify that the number of fins per inch on the coil matches the submittal data on the form, which is indicated as 8 fins per inch. Measure the coil's tube outside diameter and verify that the measurement matches the submittal data on the form, which is indicated at 0.625 inches. The recorded and verified values for H, L, DIA, SP, rows, FPI, and OD completes the data required to automatically calculate for the coil reading dimensions. These coil reading dimensions are used to measure and mark the 1 through 19 standard velocity reading locations and the 20 through 38 offset velocity reading locations. The vane anemometer positioning diagram is located on page 2 of the coil traverse data with rotating vane form. These locations are used to position the center of the rotating vane anemometer. On page 1, the coil reading dimensions A through E and U through Z automatically calculates the standard velocity reading locations. The diagram on page 2 in the top rectangle with ovals labeled 1 through 19 indicates the intersections of the standard velocity reading locations. On page 1, the coil reading dimensions A through E and M through Q automatically calculates the offset velocity reading locations. The diagram on page 2 in the bottom rectangle with ovals labeled 20 through 38 indicates the intersections of the offset velocity reading locations. The process of marking the 38 intersections for the velocity reading locations starts with the understanding how to find the intersections using the coil reading dimensions data from page 1. It is important to mention that the center of the rotating vane anemometer is placed at the intersection of each position point. Coil reading dimensions A through E are measured from the inside of the coil corner, from the left to center horizontally, and then from the right to center horizontally. E is the center of the coil. Position points on the left of E will be measured from the left to center. Position points on the right of E will be measured from the right to center. Position points along the center E can be measured from either the left or the right. Coil reading dimensions U through Z and M through Q are measured from the inside of the coil from top to bottom. Position 1 is located in the top left at the intersection of A and U. The value for A equals the diameter of rotating vane head divided by 2, and the value for U equals the diameter of rotating vane head divided by 2. Begin with position 1 and reference the coil reading dimensions. The standard velocity reading location for position 1 is at the intersection of A and U. The value for A equals 2 inches, and the value for U equals 2 inches. Since position 1 is on the left of the center, The measurement and marking for A is 2 inches from the left inside coil toward the center horizontally, and for U, 2 inches from the top inside coil towards the bottom. Therefore, the position 1 standard velocity reading location for the center of the rotating vane anemometer is at the intersection of A, 2 inches from the left to center, and U, 2 inches from the top to bottom. The standard velocity reading location for position 2 is at the intersection of D and U. The value for D equals 25.667 inches, and the value for U equals 2 inches. A measurement and marking for D is 25.667 inches from the left towards the center horizontally, and for U, 2 inches from the top towards the bottom. Therefore, the position 2 standard velocity reading location is at the intersection of D, 25.667 inches from the left to center, and U, 2 inches from top to bottom. Since position 3 is right of the center, it is measured from the right towards the center. Position 3 is at the intersection of D and U. A measurement and marking for D is 25.667 inches from the right toward the center horizontally, and for U, 2 inches from the top towards the bottom. Therefore, the position 3 standard velocity reading location is at the intersection of D, 25.667 inches from the right to center, and U, 2 inches from top to bottom. Position 4 is at the intersection of A and U. A measurement and marking for A is 2 inches from the right towards the center, and for U, 2 inches from the top towards the bottom. Therefore, the position 4 standard velocity reading location is at the intersection of A, 2 inches from the right to center, and U, 2 inches from top to bottom. Use this method referencing the coil reading dimensions for the standard velocity reading location, intersections 1 through 19. This chart documents the intersections for the standard velocity reading locations 1 through 19. Next, measure and mark the offset velocity reading locations 20 through 38 by referencing the coil reading dimensions A through E and M through Q. The same method is used to mark the intersections of the offset velocity reading locations, as was used to mark the standard velocity reading locations. The offset velocity reading location markings are a different color to differentiate between the standard velocity reading locations and offset velocity reading locations. The offset velocity reading location for position 20 is at the intersection of A and M. The value for A equals 2 inches, and the value for M equals 2.438 inches. A measurement and marking for A is 2 inches from the left towards the center, and for M, 2.438 inches from the top towards the bottom. Therefore, the position 20 offset velocity reading location is at the intersection of A, 2 inches from the left to center, and M, 2.438 inches from top to bottom. Use this method referencing the coil reading dimensions for the offset velocity reading location, intersections 20 through 38. This chart documents the intersections for the offset velocity reading locations 20 through 38. Each position consists of a standard velocity reading location and an offset velocity reading location. Now that the position point intersections have been explained, next is to watch the video as an example of how to mark the demonstration coil and the position points 1 through 38. Referencing the coil reading dimensions A through E, mark the coil horizontally, starting from the left. A equals 2 inches. B equals 13.833 inches. C equals 19.750 inches. D equals 25.667 inches. And the center E equals 37.500 inches. Then for the right side, D equals 25.667 inches. C equals 19.750 inches. B equals 13.833 inches. And A equals 2 inches. Referencing the coil reading dimensions U through Z and M through Q, Mark the coil vertically for the standard and offset locations starting from the top. U equals 2 inches. Offset M equals 2.438 inches. W equals 11.875 inches. Offset N equals 11.438 inches. X equals 21.750 inches. Offset O equals 21.313 inches. Y equals 31.625 inches. Offset P equals 31.188 inches. Z equals 41.500 inches. And offset Q equals 41.063 inches. After marking the coil's frame with the coil reading dimensions, mark the coil with the intersections for both standard velocity reading locations and offset velocity reading locations. This will map the placement for the center of the vane anemometer for each position point, 1 through 38. In the field, different colored markings can be used directly on the coil to differentiate between the standard and offset velocity reading location intersections. For the purpose of this training video and ease of visibility, colored pens were used to mark the standard and offset location intersections on the demonstration coil. Since this coil's center position point intersections were obstructed by the coil's metal frame, the center position points were marked at the closest position possible. Each of the 38 position points for standard and offset velocity reading locations have been marked on the demonstration coil. This is a drawing of the air handling unit used for the following video. Any one of these 3 coils could have been used for the coil traverse. The preheat coil B was selected because the chilled water coil's isolation valve would have to be closed to test a dry coil, which was not allowed on a 100% outside air handling unit. The preheat coil consists of 2 stacked coils top and bottom, requiring both coils to be tested with 38 readings. The demonstration coil has identical dimensions as the preheat coils. Due to the small and narrow size of the preheat coil's plenum, they were measured and marked for the standard and offset velocity reading locations prior to this video, using the same method shown on the demonstration coil. When conducting the readings, place in the vane anemometer's head parallel and flat against the coil with no obstructions so that the airflow is perpendicular, and the vane anemometer can record an accurate airflow reading in feet per minute. The following video films the bottom coil traverse. However, in the field, both top and bottom coils were traversed for 38 position points each. Starting with the standard velocity reading location, position point 1. Place the vane anemometer's head, centered over the position point 1 intersection, and lay the vane head flat to the coil. Wait a few seconds and record the reading in feet per minute. Next, move the center of the vane anemometer's head over the offset velocity reading location, position point 20, and after a few seconds record the offset reading in feet per minute. Move the center of the vane anemometer's head over the standard reading location, position point 2, and after a few seconds record the standard velocity reading. Move the center of the vane anemometer's head over the offset velocity reading location, position point 21, and record the offset reading. Move the vane anemometer over the standard reading location, position point 3, and record the standard reading. Move the vane anemometer over the offset velocity reading location, point 22, and record the offset reading. Move the vane anemometer over the standard reading location, position point 4, and record the standard reading. Move the vane anemometer over the offset velocity reading location, position point 23, and record the offset reading. Since the center position points for standard velocity reading location 6 and offset velocity reading location 25 are obstructed by the coil frame, the vane anemometer's head was positioned to the closest area possible for the velocity readings. For the remaining position points, continue to follow this procedure until velocity readings are complete for 38 position points on each coil, AHU1 top coil and AHU1 bottom coil. The demonstration coil and the AHU1 top and bottom coils have identical dimensions. The demonstration coils data from the coil traverse data with rotating vane form was used to input information onto page 1 of the AHU1 top coil and AHU1 bottom coil. On page 2 of the coil traverse data with rotating vane form for AHU1 top coil, record the standard velocity readings. Notice the average velocity at the bottom of the form is automatically calculating. Next, record the offset velocity readings. After all 38 velocity readings are recorded, the average velocity in feet per minute calculation is complete. Also, as the velocity readings are entered on page 2, the K-factor and the CFM actual values are automatically calculated on page 1. This completes the data and calculations for AHU1 top coil. Next, repeat this process for AHU1 bottom coil. On page 2 of the coil traverse data with rotating vane form for AHU1 bottom coil, record the standard velocity readings. Then record the offset velocity readings. The average velocity, K-factor, and CFM actual values are automatically calculated for AHU1 bottom coil. Each of the 4 fan inlets has a flow station, which is totalized to give the actual airflow. The Ebtron flow station's actual airflow for both the top and bottom unit totalized is 17,608 cubic feet per minute. The AHU1 top coil actual CFM is 8,480. The AHU1 bottom coil actual CFM is 9,355. with a total of 17,835 CFM. The Ebtron flow station's total is 17,608 CFM. Therefore, the coil traverse total is 1.103% higher than the Ebtron total. This completes the process using the coil traverse data with rotating vane form. Thank you. The forms and the video shown will be provided to all AABC TBEs. The formulas have been protected. Depending on the brand of printer or printer settings, the form may add a line vertically or horizontally. Please do not adjust the margins. Simply drag the line to the blue border.